Hey guys, Mr. Henry here with another video. Um, Recently we've been looking at distance time graphs, and we've talked about how sometimes on a distance time graph we see motion that is linear, meaning it's got a constant speed, and when we see it on the graph we see a straight line. So that would be what we would call linear, something that is a straight line. As well, we've seen motion graphs that have curves. So nonlinear trends in distance time graphs. What I want to talk about today is another way we can figure out if something is going to be linear or nonlinear without having to look at the graph. To do that, I want to take a look at a graph similar to the one from the very first activity this week, where we saw a man being shot out of a cannon straight into the air. And then he is falling and he deploys his parachute. So I made a graph similar to that here. So you can see this part in black is representing the nonlinear part. So I'll say this one is nonlinear. And then this other part of the graph, this was after he deployed his parachute. This part was linear. Right, when we look at the graph, we see a straight line. I want to make a table for each of these sections, just so we can take a look at the tables and see if we notice any trends there. So I'm going to start with the nonlinear part, the black part of the curve, and I'm going to fill out this first table. So basically here in my first column, I've got time. So along the x-axis, I had time, and then I'm going to fill in the y values for distance. So the first y value is actually 0 because at times when the time was 0 at the start, his height was 0, or distance was 0. This one here after 5 minutes. So obviously this is not exactly the same scale of a graph that we were looking at in that activity. Here we've got something that's got time in minutes. And our y-axis is distance from home, but it is the same sort of trend. So after 5 minutes, we can see that it is 500 meters away. So for distance, I'm going to put in 500. At 10 minutes, we are over here at 800 meters. And then at 15 minutes, we're up here at 900 meters. If I keep following that same pattern, after 20 minutes we were back down at 800, and then at 500 we were down at 25 minutes we were down to 500 meters. So we know that this was not linear just by looking at the graph. We can see that it's curved. Obviously it's not a straight line, so it's not linear. But what I want to show you guys is that we could also get that same information from the table. And that's by adding what we call first differences. And I'm just going to add that into another column here. So first differences, basically we are looking at how much the y values are going up or down. So for instance, from 0 to 500, that's going up. We have gone up 500 meters. So I'm just going to put plus 500 there. From 500 to 800, that's going up as well, but in this case we're only going up by 300. I'm going to do the same thing here from 800 to 900. That's going up by 100. If you're unsure of how to get any of those calculations, maybe they're not nice multiples of 100 in a different example, you could just subtract them, right? 900 minus 800 is going to be 100. For the next part, it looks like we're starting to go down. So from 900 to 800, we're actually going down by 100. And then from 800 to 500, we're going down again, this time by 300. I want to do that exact same thing for the linear part of this scale as well. The linear part of this graph as well. So at 25 minutes, We are still in that same spot here of 500 meters. At 30 minutes, we are down to 400 meters. At 35, we are down to 300 meters, then 200, then 100, and then 0. And so what I want to do is also find the first differences here. And let's take a look at that. So from 500 to 400, it looks like we are going down, and we've gone down by 100. And again, if you're unsure, you could subtract them. Just take the second one and subtract the first one. So if I do 400 minus 500, that's going to give me negative 100. If I do the same thing for the next two, 300 minus 400, that's also negative 100. Right? Or if you're comfortable just looking at the numbers, you can see, for instance, in the next one from 300 to 200, that's also down 100. This one is also down 100. And then this one is also down 100. So as we can see, there is something different going on here. Our first differences in this one, these were all the same. So we have first differences that are constant. That actually tells us that our graph is linear. We know that, and as well, we can look at the first differences from the other part, the nonlinear part, and we can see that they're all different. We got 500, 300, 100, negative 100, and negative 300. That tells us that this part of the graph was nonlinear. Nonlinear. So say, for instance, you did not have the graph. We didn't have any of this information. We just had the tables. You could go ahead and do this exact same thing. Find these first differences. And you'd be able to figure out if the graph would be linear or nonlinear just by subtracting these values and seeing if you get the same thing. So from this video, what you should be able to take away is that if you have a table of values, we can figure out whether it's nonlinear or linear. To do that, we're going to calculate our first differences and see if they're the same. If they are all the same like the second one, then we know that it's linear. If they are not all the same, then we know it is nonlinear.